So 2.2, we are going to talk about coordinate geometry. Now, under coordinate geometry, we say 2.2.1. We'll see the distance between 2 points. Distance between 2 points. Distance between 2 points. Okay. Given that A with the point x1, y1, and B are points on an xy plane, as shown below. This is the y-axis, this is the x-axis. Now let's consider these 2 points. Okay, let's consider this point as this point A. Sorry that it has a horizontal displacement of x1 and a vertical displacement of y1. And consider this point here as B with its horizontal displacement of x2 and vertical displacement of y2. Now, the distance between these 2 points is what we're interested in. How do we find the distance between A and B? First of all, we need to find what is the distance between these 2 points. So if I call this point C, we need to figure out what is AB and BC. But AC is what? AC is clearly x2 minus x1, and BC is what? BC is y2 minus y1. Okay, exactly. AC is what? x2 minus x1. BC is y2 minus y1. Now remember, we are looking for AD and AB, and AB we can call it D. That's what we are looking for. Now we see that ABC is a what? It's a triangle in brackets, a right angle triangle for that matter. ABC is a right angle triangle. So Pythagoras theorem applies. That is, AB squared is equals to AC squared plus BC squared. That is, D squared equals to x2 minus x1 squared plus y2 minus y1 squared. Therefore, the distance between A and B is simply the square root of x2 minus x1 squared plus y2 minus y1 squared. Very important formula. We can call this our formula number 1. So example 1, we'll say find the distance between we can take 2 1 and minus 1 minus 3. Okay, let's call this P and Q. Okay, now this is simple. We know the distance between P and Q, that is PQ, is the square root of what? X2 minus x1 squared plus y2 minus y1 squared. Okay, where our P, we take it to be x1, y1, and that is clearly 2 1, and our Q, take it to be x2 and y2, which is -1, -3. Okay, so PQ is simply the square root of x2, that's -1 minus x1 2 squared plus y2, that's -3 minus y1, which is 1 squared. Therefore, you have the square root of -3 squared plus -4 squared, and this is exactly the square root of 9 plus 16, which is the square root of 25, and this clearly is what? 5. Okay, so the distance between P and Q is exactly 5 units. So we're going to 2.2.2. 2.2.2, we'll talk about the midpoint of a line. The midpoint of a line joining two points. So we'll say consider as before A x1 y1 and B x2 y2. Okay, and let's see with coordinates xy be the point midway in what? AB. Okay, as illustrated below. So this is the XY plane, and let's say this is x1 y1, so that's the point A. This is y2, this is x2, and the point C should be somewhere here. It has to be midway. So we called it x, y. If you complete this to form a right angle triangle, we can call this is P. We can call this place, this point D. Okay, and we call this point E. Okay, now you see that from the graph, AB AC is equals to what? CP. Since what? Since C is the midpoint, of the line what? AB. Okay. As a result of this, it follows that AE is equals to ED. Good. So what does this mean? But AE is x minus x1, and what? ED is what? x2 minus x. So A equals to ED implies x minus x1 is equals to x2 minus x. Making x the subject, we have 2x equals to what? x2 plus x1. Therefore, x is equals to what? x1 plus x2 all over 2. Okay. Similarly, we do know that from here, if you extend this line like this and call this F, we do know that BF is bound to be equals to FD, simply because AC is equals to CB. But BF is Y2 minus 1, and FD is Y minus what? Y1. So BF equals to FD implies Y2 minus Y equals to Y minus Y1. And this further tells us that Y2 plus Y1 equals to 2Y, and therefore Y is equals to Y1 plus Y2, all this over 2. Hence, the coordinate of the midpoint C, which is xy, is equals to what? What is x? We saw x is x1 plus x2 all over 2. And what is y? We saw y is y1 plus y2 all over 2. Okay, this is the equation of the midpoint between two points. Okay, so that will be our equation 2. Example: find the midpoint. Of the points. Minus 2, 1, and what we'll call the minus 2, 1, and 3. Okay, let's take 3 and 4. Yeah, 3, 4. Solution. You see, the midpoint from what we saw is what? X1 plus X2 all over 2, Y1 plus Y2 all over 2. If I take this to be the first point, so this will be X1 and Y1, and take this to be the second point, so this will be Y1, X1, X2 and Y2. That simply implies we have X1, which is minus 2, plus X2, which is 3 all over 2, and then Y1, which is 1, plus Y2, which is 4 over 2. So what do we have? Minus 2, that's 1, so we have half here. This is 5 over 2. So this is the midpoint of these 2 points. Okay. So 2.2.3, we will talk about the gradient of a line joining 2 points. Okay. Gradient of the line joining 2 points. Consider the points A, X1, Y1, and B, X2, Y2. As shown. So this is the y-axis, this is the x-axis. So we are looking at this point A, this point B. Of course, this is x2, this is x1, this is y2, and y1. Okay. Sorry for the marker. So now if you extend this to form a right angle triangle here, and call this side C. Okay. To find the gradient is simple. See, the gradient of AB is simply what? The change in the y axis all over the change in the x axis. Okay, literally we denote the gradient as m. So we are changing y all over change in x, where the change in y is this and the change in the x-axis is here. Now what is the change in y? Change in y is the same thing as BC, and change in x is the same thing as what? AC. And we know BC is what? BC is what? Y2 minus y1, and AC is what? X2 minus x1. So the gradient is y2 minus y1 all over x2 minus x1. This is a gradient of a line A, B. Let's look at some example. Now, if you are asked to find the gradient of the point, find this marker. Find the gradient of the point. We have let's say 1343. 1343. Okay. Solution. We know that the gradient is actually equals to what? y2 minus y1 all over x2 minus x1. We should take this to be the first point and this to be the second point. So we are going to have y2, which is what? 3, minus y1, which is in the first point, that is 3, all over x2, which is what? 4, minus what? x1, which is what? 1. So basically we have 0 over 3. So therefore the gradient is what? 0. Yeah. Example 2. Find the gradient between, we're given the points, let's say A is -1, -4, 2, and B is okay, let's take negative numbers again. Yeah. So if we find this gradient, okay, let's make this one also minus. So whatever. Solution. We call this our first point and call this our second point. So the gradient, which is equals to y2 minus y1 over x2 minus x1, simply give us what? y2, that's 1, minus x1, y1, which is minus 2 all over x2, that's what? Minus 1, minus x1, which is what? Minus 4. Good. So we have 3 all over what? All over 3. Okay. Therefore, the gradient is simply what? 1. Okay. So we are going to look at the equations. The equation of a straight line. Equation of a straight line in gradient intercept form. Consider the illustration where this is the y-axis, this is the x-axis, and then if this is a certain line such that P here is an arbitrary point on that line xy, okay, and if we take this slope, this change in y is, and this is also a change in x, okay, we see that change in y is actually y minus, okay, this point, we are going to allow this point where the line cuts the x-axis C, okay, the intersect point. Good. So actually here is x is 0, but y is C, okay. So we have that the change in y would be what? The y value, and it's at this point we have y, and at this point we have x. So we have the y value minus the point here, which is c. Okay, and the change on the x will be the x value minus the origin, which is 0. Okay. So let's write something. We'll say let the line cut the y-axis at the point 0c. Okay, and let P be an arbitrary point, or in other words, a general point. A general point on the line. If you let M be the gradient of the line, okay, we have that M will be about the change in y over the change in x. That is clearly y minus c over x minus 0. Okay, or we have M is equals to what? Y minus c over x. Cross multiply, this gives us mx equals to y minus c. Therefore, the general equation of a line cutting through the y-axis is y equals to mx plus c. Now, we'll look at some example. Let's say a certain line has gradient 4 and intercept on the y-axis as -6. If you are asked to state the equation, okay, how do we work this out? Now, you see the gradient intercept form of the equation of a line is what? The gradient intercept form of the equation of a line is y equals to mx plus c. Okay, but we are told that the gradient is 4 and the y-intercept -4. Therefore, y is equals to 4x minus c. Example 2. Now, if you are given the equation of a line 5y minus 4 equals 3x, then you're asked to state the gradient and the intercept. The intercept on the y-axis. Okay. Now the best way to approach this problem, we write first the equation out. We have 5y minus 4 equals to 3x. This implies 5y is equals to 3x plus 4. Now dividing all through by 5, we have y equals to 3 over 5x plus 4 over 5. If you comparing with y equals to mx plus c, we see clearly that that the gradient is equals to 3 over 5, and the y-intercept is clearly 4 all over 5. Now consider the xy plane with a line that cuts across the y-axis. Now if P here is a point, it's a given point on the xy plane, we can say P is this point. Let's call this the point P. Of course, this is x1, here we have y1. Now for any other point, like let Q be an arbitrary point on the line, call it xy. Okay, we can have the gradient from here, because this is the point x and this is the point y. Here we have a change in x, then a change in y. Okay, the change in x is clearly x minus x1. Change in y is clearly y minus y1. Okay, so we can say let P be the non-point on the line with coordinates x1 y1. Okay, and Q be an arbitrary point or a general point with coordinates x, y. If also we let the gradient of the line passing through P be m. Okay, then by definition of the gradient, m, which is equals to delta y over delta x, is equivalent to what? Y minus y1, x minus what? x1, or m m into x minus x1 equals y minus y1. Thus, y minus y1 equals to m into x minus x1, okay, is the equation of a straight line. Equation of a straight line passing through the point x1, y1, and having what? Gradient of m. A straight line has gradient 6/7 and passes through 4, 6, the coordinate point 4, 6. We have to find the equation and to state the intercept on the y-axis. Now, what is given? We are given the gradient to be 6/7 and the point P, x1, y1, to be what? 4, 6. As we know, y minus y1 is equals to m into x minus x1. It follows that y minus what? y1 is 6, m is 6/7, so x minus 4. From here we have y minus 6 equals to 6/7x minus 24/7. This implies y is equals to 6/7x minus 24/7 plus 6. So we have y equals to 6/7x 18/7. Okay, so this is the equation of the line, and thus the intercept is what? Minus 18/7. Oh, my mistake. It's positive 18. Positive 18/7. Now, to find the equation of a straight line knowing 2 points, the first thing we do is step 1. We use the 2 points to obtain the gradient. That is, if P and Q are the points, then the gradient will simply be y2 minus y1 over x2 minus x1. Then for the next step is use any of the points along with the equation we derived. Thus, y minus y1 equals to m into x minus x1. So obtain the equation of the straight line. So the first thing we do here is to find the gradient. The gradient, okay, let's first of all call P the point 1, sorry, minus 3, and Q the point 2 minus 2 over 3. We know m is equals to y2 minus y1 over x2 minus x1. If you take this as the first point, this is the second point. So we're going to have minus 2 over 3 minus 4 over 3 divided by 2 minus 1. So we have here 2 minus 2 plus 4, that is 2 over 3 divided by 1. So basically I have 2 over 3 as the gradient. Okay. Now for y minus y1 equals to m into x minus x1. Okay. If we use this with the equation 1 minus 4 all over 3, we are going to have y minus 4 over 3 equals to 2 over 3 into x minus 1. If you open the brackets, we have y plus 4 over 3 equals to 2 over 3x minus 2 over 3. So y is equals to 2 over 3x minus 2 over 3 minus 4 over 3. This is identical to 2x all over 3 minus 6 all over 3. So therefore we see we have y equals to what? 2 over 3x minus 2. Consider the illustration. We have a line here, we can call it L1. Notice that this line makes a certain angle, let's say theta 1, with the x-axis. This is our y-axis. Okay. Now the gradient of this line is obtained by just taking a particular, if I consider a particular point here. Okay, I consider this point P. We call it P. The value of x here, the gradient, we call it x, and its corresponding y value is y. Okay, you notice that the gradient of the line L1 is what? The change in y over the change in x. That is, the change in y, we have y minus what? The origin. Over the change in x is x. X minus, okay, this point where it cuts the x-axis, we can call it x naught. So we have x minus x naught. Okay. Now, you notice that also, what is tan theta 1? Tan theta 1 is the opposite, this side, the opposite, which is clearly the change in y. That is delta y over what? The adjacent, which is delta x. And those are clearly what? Y minus 0 over x minus x naught. I see that that's the gradient. So what am I heading to? My point is the gradient of the line L1 is what? Is m1, which is equals to what? Tan theta 1. Okay, that is a fact. That is the angle, the tangent of the angle the line makes with the x-axis is equivalent to the gradient of that line. Now, if we consider two of those lines, L1 and L2, and we allowed the angle between them to be alpha, okay, as shown. This is L2, this is L1, call this theta 2 and this theta 1. Okay, this is the y-axis, this is the x-axis. Now, we know what this angle is going to be. That angle is simply 180 degrees minus theta 2. Okay, so we're going to have here, as we have a triangle. It's an angle of 180 minus theta 2, theta 1, and this alpha. Okay, so that's the triangle we have. Now we see that the sum of interior angles is what? 180 degrees. That is alpha plus theta 1 plus 180 minus theta 2 equals to 180 degrees. So that's alpha plus theta 1 minus theta 2 is equals to what? 0 degrees. This goes there, it cancels 180 degrees. So what are we saying? We're saying that alpha is equals to theta 2 minus theta 1. By law of trig ratios, the tangent of A plus B, the tangent of A minus B, is equals to the tangent of A minus the tangent of B all over 1 minus the tangent of A times the tangent of B. Sorry, 1 plus tangent of. Okay. Hence, this is a fact. Hence, the tangent of alpha should be equal to the tangent of what? Theta 2 minus theta 1, which is equals to, by this fact, the tangent of theta 2 minus the tangent of theta 1 all over 1 plus tangent of theta 2 times the tangent of theta 1. Okay. Now, we know that the tangent of theta 1 is the gradient, and the tangent of theta 2 also will be its gradient. So tangent of alpha, that's the angle between those two lines, will be m2 minus m1 over 1 plus m2 times m1. Note: if m2 minus m1 over 1 plus m2 m1 is less than 0, okay, then the angle between the pair of straight lines is obtuse and is given by 180 degrees minus the absolute value of alpha, or simply 180 degrees plus alpha. Okay, and the acute angle, between a pair of lines is obtained when what? The opposite happens. When m2 minus m1 over 1 plus m2 m1 is greater than 0. So whenever you're asked to find the acute angle between a pair of two lines, you simply have to take the absolute value of this rational expression. Okay, very important. So examples. Now if we say find the angle between, you have 3x minus 4y minus 8 equals to 0 and x minus 6y minus 5 equals to 0. What you do here is you write them first in their standard form. for 3x minus 4y minus 8 equals to 0, minus 4y is equals to what? Sorry, plus 4y if I take the other side equals to 3x minus 8, and so y equals to 3 over 4x minus 2. So that is, if I call this the first line, okay, and for the x minus 6y minus 5 equals to 0, if I call this the second line, send this to ourselves. So we have 6y is equals to x minus 5, so y is equals to 1 over 6x minus 5 over 6. See, comparing with y equals to mx plus c, we see that the first gradient, the gradient for the line is what? Is 3 over 4, and the gradient for the second line is 1 over 6. Now we are asked to find the angle between them. We know that tan alpha is equals to m2 minus m1 over 1 plus m2 m1. That's basically 3 over what am I saying? 1 over 6 minus 3 over 4, what is divided by 1 plus 1 over 6 times 3 over 4. Okay. So we have minus 14 over 24 divided by 1 plus 3 over 24. Now this clear is minus 14 over 24 times times 24 over 24 plus 3. That's going to give us minus 14 over 27. So tan alpha is negative 14 over 27. Now the negative sign tells us that this angle alpha is an obtuse angle. Okay, so when you take the tan inverse on both sides, we see that alpha is equals to tan inverse of negative 14 over 27, which is what? Okay, now that we know that, we see that the angle is negative, we find it's clear that it's an obtuse angle. So what we do is, to get the solution, let's recall this. Remember, we said something about the notes that if it is less than 0, that is negative, those coordinate expression. To get the angle, which is obtuse, is by doing what? 180 minus what? The absolute value of that angle, or 180 plus alpha. So thus the angle between the line is what? 180 degrees plus alpha. That is 180 degrees plus minus 27.4 degrees. find the angle between these two lines. Now here they specify the acute angle. Okay, since they specify the acute angle, first of all find the gradient, respective gradients. Okay, now let's say from solution, I'll show this marker. For the solution, we have the first line, you have line x minus 4y plus 2 equals to 0. Okay, so from here we can have 4y equals to x minus 2 and y equals to 1 over 4 x minus half. So we can say our m1 is 1 over 4. The second line we have x minus 3y minus 2 equals to 0. From here we see that 3y is equals to x minus 2, y is equals to 1 over 3 minus 2 over 3. So our m2 is 1 over 3. Of course, tan alpha is now the absolute value, because you are specifically said an acute angle. So the absolute value of 1 all over 3 minus 1 over 4. All this divided by 1 plus 1 over 3 times 1 over 4. This itself is going to give us 1 over 12 all over 13 over 12. So see, you're going to have exactly 1 over 13. Okay, yeah, 1 over 13, and the absolute value of 1 over 13 is simply 1 over 13. Okay, now what will be alpha? The tan inverse of 1 over 13. Which is clearly the tan inverse of 1 over 13, approximately 4.4 degrees. So this is the angle, the acute angle between those two lines.